Yes, good afternoon everybody. Welcome to this session of Sustainable Construction Methods. I myself Irfan Ahmed. I'll be continuing with the previous topic of admixtures. In the previous class, as we had seen what is admixture, what is the importance of admixture, what different types of admixtures we have. We have water reducing admixtures, we have air entrainment admixtures, and all these admixtures, some of them are all these admixtures we had seen, but still we had to see what is the we had seen till plasticizers. We'll be seeing what is accelerating admixtures, retarding admixtures, as well as hydration control admixtures. What we had seen till plasticizers, how the plasticizers increase the workability of the concrete, and what happens when we are going for a huge structures where the concrete have to be pumped to a very high place. That times what happens if the concrete is very heavy, as the concrete is already heavy. If the concrete is heavy, we want to reduce that weight of the concrete. Thereby we just can't keep adding water, as if we keep adding water the slump will reduce and the desired strength can't be achieved. Under those conditions, then we go for plasticizer. So we had seen what is the importance of air entraining admixture, water reducing admixtures, as well as plasticizers. Here we'll be seeing what is the importance of accelerating admixture, retarding admixture, and hydration control admixture, as well as corrosion inhibitors, and the next is the shrinkage reducers, alkali silica reactivity, as well as coloring admixtures. Let us see what role do they play. We had seen all this in the previous class. I'll be just moving away with these slides, and we'll be going to the slides which we are concerned about. We had seen how the frost damage takes place because of non-existence of air entraining bubbles into the concrete, where we go for those admixtures which air bubbles can be induced into the concrete. Thereby it can reduce the frost of the concrete. So this we had seen the frost induced cracking near joints, how they are formed, and the scaling of concrete, how this happens. All this was seen. Let us see here water reducing admixtures, why the water reducing admixtures are added, and what content of water is reduced. About 5 to 10% of water is reduced when this type of admixture is added into the concrete. Here you can see this how do they perform. This is the graph. In just 40 minutes it performs up to 75 mm slump, whereas the normal mixed concrete it takes about 130 minutes, about 2 hours, and the slump that is gained is about 100 mm, that is after 2 hours, whereas just in 40 minutes 80 mm of slump is gained here. This is the benefit of adding this type of admixture, and this is the plasticizer, super plasticizer. Why do we add it? As I had explained you very specifically in my previous session. Let us see here. We had seen till here how this type of plasticizer is added into the concrete and how do they perform. Thereby the free flow of concrete is also achieved, and the strength is also gained, and the split tensile strength, as well as compression strength and flexural strength, all this type of strength are achieved. Desired strength is also got, as well as the free flow of concrete is also got. Let us see further. So what does this super plasticizer contain? This super plasticizer contains of typical super plasticizer include sulfonated melamine formaldehyde. So it consists of this chemical, that is sulfonated melamine formaldehyde condensate. So this is the chemical which is added when this chemical is mixed with sulfonated naphthalene formaldehyde condensate. This type of super plasticizer is got, and it acts and the benefit of adding this super plasticizer into the concrete, it increases the strength as well as the slump also. You can see lignosulfates are also there. It consists of this also, as well as polycarboxylides. All these different chemicals are mixed in different quantities. Thereby the super plasticizer is achieved, and it performs very well when mixed into the concrete. Thereby where the concrete plant, if the concrete plant is very far, we don't want the concrete to set in, as well as we want the slump of the concrete to be good, as well as we want the desired strength of the concrete also. Then under those conditions, this type of super plasticizer, which consists of all these chemicals, is added. Let us see here. in the next slide, retarding admixtures. What do these retarding admixtures do? You can see here they are used to retard the rate of setting of concrete at higher temperatures of fresh concrete. See, we want to reduce the setting time of concrete when there are very high temperatures. You can see here, used to retard the rate of setting of concrete. We want to reduce the setting time of concrete at high temperatures of fresh concrete. When fresh concrete is placed there, and there are very high temperatures, that is about 30 degrees Celsius or more. If you are working under conditions where the temperature is about 40 degrees Celsius and 50 degrees Celsius, you can understand how the water evaporates from this concrete. Now what happens, just when the water evaporates from the concrete tries to set in, it tries to get hardened. So we want to reduce this setting time of concrete, thereby we add this retarding admixture. One of the most practical methods of counteracting this effect is to reduce the temperature of the concrete. What we are doing is, when the temperature already, because of different materials getting mixed into the concrete, the temperature of the concrete also increases. Basically there is cement, there is hydration of cement also. Then with the cement, if we are going from some other mineral admixtures such as different cementing materials, where we are replacing it with silica fume, or we are replacing it with fly ash or different other materials, what happens when these materials also react with the cement, the temperature of the concrete also increases. Once the temperature increases, the evaporation of water also takes place. So we have to reduce this temperature of the cement. Thereby we add this retarding admixture here by cooling the mixing water of the aggregate. We are cooling the mixing water of the aggregate, thereby the temperature is getting reduced. Once the temperature is getting reduced, the vaporization won't take place, and because of that the setting time of concrete can be maintained or it can be delayed here. Retarders do not decrease the initial temperature of concrete. The bleeding rate and capacity of plastic concrete is increased. You can see here the bleeding rate and capacity of plastic concrete is increased with retarders. Plastic concrete means the free flow of concrete. That concrete which is in a free flow form, that can be increased because of this retarding admixture. So this admixture also plays a very important role in those conditions where the climate is very hot, more than 30 degrees Celsius. There are many countries where the climate is about close to 50 degrees Celsius, also 40 to 50 degrees Celsius. Under those conditions also, if this retarding admixture is not mixed, then there are high chances of the water getting evaporated, and thereby the desired strength of concrete will not be achieved here. So this is how the retarding admixtures slow down the setting of the concrete, they reduce the temperature of the concrete, and this is how they do it. Let us see retarding admixtures. What do they consist of? The typical materials used as retarders are lignin, borax, tartaric acid and salt. So these are the different materials which are used as retarders to reduce the setting time of concrete, to reduce the temperature of the concrete, and this type of retarding admixtures are used in places where there is where the temperature of the in that region is very high. So let us see. You can just see how do they perform, when this retarding admixture is mixed into the concrete, how does it perform. This is a chart where you can see here, there in this red part is where this concrete, there no admixture was added into it, and this blue line, it shows that no admixture at 32 degrees Celsius. You can see this is at 23 degrees Celsius, this is at 23 degrees Celsius, and this is at 32 degrees Celsius. We are trying to see how does this admixture perform when the temperature is increased. Let us see, in the same 32 degrees Celsius, the retarder has been mixed into this concrete at 32 degrees Celsius, and we want to see how the setting time is being reduced. Let us see here, the slump has to be maintained, the setting time has to be maintained, everything has to be seen. So here you can see this this is the elapsed time in minutes. You can see a slump loss at various temperatures for conventional concrete prepared with and without setting retarding mixture. This is how it is seen here. Let us see how do they perform. You can see this is the slump in mm, that is this blue part. You can see no admixture. The slump is getting increased at 125 mm, but the time elapsed is about 80 minutes it is taking to increase the slump content here of the concrete here. And here you can see the normal mix is it's taking about 120 minutes, where the slump is about 100 mm. And same way you can see here, when the retarding admixture is added into this concrete, you can see only about 60 to 70 minutes it is taking, and whereas it is again gaining the slump of about 100 mm here. 100 mm of slump is achieved with only mix of some quantity of admixture, whereas the elapsed time is only about 60 to 70 degrees Celsius. So this is the benefit of using these admixtures, where the setting time also can be reduced also. The setting time is getting reduced also. So here, so this is the importance. Let us see what is accelerating admixture. Hope you can understand with the name itself, where this admixture is used to accelerate the setting time of concrete. There in the previous slide we had seen the setting time of concrete and the other properties were reduced, whereas in here we are trying to accelerate all these things, used to accelerate strength development of concrete at an early stage. What we want to achieve is, basically you must have seen the compressive strength of concrete is different at different stages. In after 7 days of curing, you can see what is the compressive strength of concrete, and next we see for 21 days and 28 days. At 28 days most of the strength is achieved, that is about 99% of strength is achieved at 28 days, whereas we want to increase this compressive strength by reducing these number of days also. And under those conditions, because we have back-to-back constructions, or at those places where we are constructing, we have stopped the water body and we are constructing a dam or a barrier, and in those conditions we can't stop those water bodies for a long time. There we use this admixtures, where within a very less time, with a very less span, we can get the desired strength of the concrete here. So typical materials which are used in this accelerating admixtures is calcium chloride. This is the most commonly used for plain concrete. When plain concrete is used, we use this calcium chloride. This is used at the accelerating admixture here. It accelerates the mix, it accelerates the property of concrete, it improves as the strength of concrete also. There we have triethanolamine also. This is also used as an accelerating admixtures, as well as we have calcium formate also. Calcium formate also, it works very good when mixed as an accelerating admixture. The performance also is very good, as well as the strength also what we gain after 28 days of curing also, even that is also increased because of using this type of admixture. Calcium nitrate is also used, and calcium nitrite is also used. All these are the different chemicals which are used as accelerating admixtures when under those conditions where we want to accelerate the early setting of concrete, as well as the early strength of concrete is also needed to achieve. Here let us see a corrosion inhibitors. What we want from this corrosion inhibitors, how do they perform? What is corrosion inhibitor? Corrosion inhibitor, as I had told you, at some places where the corrosion takes place and the concrete, the reinforcing steel is getting corroded because of contact of water. Under those conditions where this scare is there, we'll have to go for this type of admixture where the corrosion can be reduced here. The chlorides can cause corrosion of steel reinforcement in concrete. Normally these chlorides, they cause corrosion of steel in concrete. Now we have to come up with some solution where this chloride attack can be stopped, and thereby the reinforcement the corrosion in the reinforcement can be reduced or delayed. So when this is the need, what we do is ferrous oxide and ferric oxide form on the surface of the reinforcing steel in concrete. So what forms on the concrete? That is ferrous oxide and ferric oxide. They form on a layer is formed on the surface of the concrete. There what we'll have to do is then we have to come up with something where we can reduce this formation, the layer of ferrous oxide or ferric oxide. This layer has to be removed from the concrete, from the reinforced steel. If we don't remove this layer from the reinforcing steel, then what will happen? The whole steel will be corroded and thereby the strength of the concrete will be reduced. Ferrous oxide reacts with chlorides to form complexes that move away from the steel to form rust. So a rust is formed onto the reinforcing steel, and thereby it damages it completely damages the steel and thereby reduces the strength of concrete, and as well as the lifespan of the structure is also reduced because of this rust coming onto the steel. The chloride ions continue to attack the steel until the passivating oxide layer is destroyed. So there is basically there is an inner layer in the reinforcing steel. It goes till that inner layer. It tries to destroy that inner layer, and if this is not stopped, once that inner layer is destroyed, then the whole reinforcing steel gets weakened, and thereby there can be collapse of the structure also. So to overcome this problem, we have to go for corrosion inhibitors. They play a very good role in reducing this corrosion of steel. Let us see. You can see this pictures here, how the steel is getting corroded. This is a beam, and likely there might be some water seeping into this structural element. Because of that seepage of water and chloride acting, as I had told you, ferrous oxide layer forms onto this steel, and thereby that damages the steel or the inner part of the steel also, and this weakens the structure. You can see at this places also, this is your steel which has already got damaged because of the chloride acting onto this steel. So we have where there are chances of the chloride acting and then the water reacting with this reinforcing steel, we have to go for corrosion inhibitors or corrosion admixtures, as you can say. So we need to add this corrosion inhibitors into the concrete at the time of laying also. So they form a layer onto this reinforcing steel, and thereby they reduce the damage of the corrosion onto the steel, and thereby reducing the rust that gets formed onto the steel. So let us see here. Corrosion inhibitors, what do they consist of? Corrosion inhibiting admixtures chemically arrest the corrosion reaction. They reduce the chemical reaction. Basically they reduce the chemical reaction completely also, and sometimes to a very good level they reduce the corrosion. Commercially available corrosion inhibitors include calcium nitride. So this is the calcium nitride here. You can see here calcium nitrite is used here. Calcium commercially available corrosion inhibitors. So this is the commercially available corrosion inhibitors is calcium nitrite as well as calcium nitrate is also, sodium nitrate is also there. So these are the very easily available corrosion inhibitors. When mixed in concrete, they reduce or they arrest the chemical reaction that takes place between the chloride and the reinforcing steel. You can see dimethyl ethanolamine. This is also very easily available, which acts as a corrosion inhibitor, as well as amines and phosphates and ester amines also. All these are the different corrosion inhibitors which, when mixed in concrete, play a very important role in reducing the corrosion of the steel as well as increasing the lifespan of the structure also. So this is corrosion inhibitor. You can see shrinkage reducing admixtures. What happens? Shrinkage cracks such as shown on this bridge. A deck can be reduced with the use of good concreting practices and shrinkage reducing admixtures. What happens? There is shrinkage in concrete also. Shrinkage takes place in concrete when because of the climatic conditions, where the climate is very hot, then the water evaporates. There is some shrinkage action happening into that concrete. Now to reduce that shrinkage action coming onto the concrete, we have to add this shrinkage reducing admixtures, or travels, then the damage, you can see the damage that is caused onto the surface of the concrete will be in this way. You can see this damage onto the surface of the concrete. Once this surface is damaged, then there are chances of the damage onto the bottom layers of the concrete also. So to reduce this damage of shrinkage, then we go for shrinkage reducing. We mix this type of admixture, shrinkage reducing admixture. It is very beneficial. It plays a very good important role in reducing the shrinkage also. Next we have this coloring admixtures. This is a very unique admixture where though it doesn't increase the strength of the concrete, it doesn't increase the reduces the setting time of concrete or any other properties. It doesn't play important role in improving the properties of the concrete, but on the other hand it gives you a very aesthetic view. The concrete itself comes up in a coloring form. You can see red and blue pigments were used to color this floor. This red and blue pigments, these pigments were mixed into the concrete while laying only. Once they were laid, you can see this concrete performed as if something was painted onto this. It looks like that, but this pigments were mixed into the concrete and they were laid. So this type of admixture also plays a very important role in terms of aesthetic view, whereas the properties, to increase the properties and the strength of the concrete, different other admixtures are available. So basically with the construction taking place at a very rapid pace, and with developments coming, with huge technology coming up and developments coming up where there are big concrete plants coming up, where the concrete is mixed at the plant and transported onto the site there, and different conditions, as the site is very far away from the concrete batching plant. Under those conditions we have to come up with some admixtures which they can reduce the setting time as well as they increase the workability, at the same time increase the strength of the concrete. We can't manage or we can't compromise with the reduction in the strength of the concrete. Thereby, when these types of admixtures are added into the concrete, they perform very well under these conditions as well as increase the strength of the concrete also. So admixture is a very important role it plays in the laying of concrete as well as setting of concrete and gaining the strength of the concrete. So hope it was clear up till here. I request all the students to please go to this lecture, and if you have any questions you can comment in the comment section. Thanks a lot. Thank you.